Hi friends, welcome to Life with YouTube channel. So we have discussed till now many topics based on the maths, right? So today I am going to teach you physics of the chapter Thermodynamics. Many people were confused in the chapter, I think so. No, not confused. Many people were confused only on the problems, not on the theory part. They'll understand everything, but they're confused in problems. So I'll teach you everything. So let's see now. So today we are going to discuss thermodynamics. Let's write it here. Thermo. Just wait a minute. Clean this. Okay. Thermodynamics. Oh shit. Okay. Thermodynamics. Thermodynamics. Okay. Here, if you see thermodynamics, everyone will start the lesson by saying it's chapter and they'll start, right? It's not like that. First of all, the chapter name. What is the chapter name? What is the meaning of that? We need to know it now. So, thermo. What is mean by thermo means heat. Okay? Heat. After dynamics. What mean by dynamics means motion. Therefore, what is the meaning of thermodynamics means heat in motion. Okay? Heat in motion. Okay? Do you understand this now? Okay, is it clear? Heat in motion. So, let's start this thermodynamics chapter by saying you one of the equation. Okay? And therefore, the equation is system plus surrounding is equal to universe. Okay? System plus surrounding is equal to universe. What is system? The part which is under investigation. Okay? The part which is under investigation or simply which is under observation. What is mean by system? The part which is under investigation or observation is called system. Okay? Is it clear? So, for example, for a physicist, observing temperature in thermometer. Okay? In thermometer. So, yes, it's right. What I said, what is mean by system? If anything, the part which is under investigation or observation, right? Here, the doctor observes, right? So, what? It is a system. Okay? So, now, what is mean by surrounding? Surrounding is nothing but except a system. Except a system, everything in the universe is surrounding itself. Okay? Universe, you know, what is universe? Surrounding, you know. System is the part which is under investigation or observation. So, example, I said you this, and the surrounding is nothing but except a system is everything is surrounding. And if we combine these two, it gives us universe. Okay? Now, here, the system and surrounding is separated. We can say it's just separated, or else it was based on those means it was based on the boundary. These two are separated by boundary. Here in boundary there are two types. Here it may be a rigid or flexible, or it can be a real or imaginary. real or imaginary, or else, I mean here these two, but it can be based on diathermic or adiabatic. Okay, it can be a boundary which in system and surrounding it was divided by a boundary in which the boundary can be a rigid or flexible or real or imaginary, but the system can be divided into two types, that is diathermic system and adiabatic system. Okay, till now everything is clear, right? Here, what is mean by diathermic? Diathermic is nothing but heat flows easily. Okay, heat flows easily because the walls of that system was the walls of that is made up of conducting material. Okay, conducting material. What is mean by conducting? Conducting material is nothing but which makes heat to flow. Okay, heat flows, right? Now here in adiabatic, heat does not flows. Heat does not flows. Okay, now so here the walls of that is made up of insulating material. Is it okay? I think so. Yeah. Are you understanding this? Is it clear? I said now conducting and insulating. Okay? So here conducting and insulating. Diathermic, in which heat flows easily, which is made up of conducting material. Here heat does not flows. So insulating. Here I write for insulating, in which heat does not flows. Okay, here in this insulating, one of the important is Q is equal to 0. Q is nothing but heat. Heat does not flows now, so the changing heat is equal to 0. In here I'll write here also. Okay, till here is everything understand you? Okay, please note down this. First, system, surrounding, universe. System plus surrounding gives us universe, in which system is the part which is under investigation, and except system is everything is surrounding. If we combine these two, we will get universe. These two are separated by a boundary, in which boundary can be a rigid or flexible or real and imaginary. Either there are two types of systems, diathermic and adiabatic. Diathermic is made up of conducting and adiabatic is made up of insulating. Okay. So now let's discuss next topic. So now the next system we are going to discuss is types of systems. Types of systems. Types of systems. There are three types of systems. Types of systems. There are three types of system. Those are open, closed, isolated. Okay, open, closed, isolated. In open, mass plus energy, don't think in that way. Mass energy as well as energy exchange takes place in open. Okay, mass energy and energy exchange will take place in open system, because I'll explain you with an example of diagram. Suppose if you think it is a beaker consisting of a liquid, so due to the temperature the mass can exchange Okay, as it is a made up of conducting material, here no heat can, energy can, in conducting, as I said, heat can flow easily. So here energy can exchange. So therefore mass and energy exchange takes place in open type of system. Closed type of system, only energy takes place, because in the name itself we have, it is a closed. If it is a closed, because of temperature there will be no mass exchange, as it is a closed lid. So therefore, if this liquid is made up, the walls of this made up of conducting, here energy exchange takes place. So it is a closed type of system. Okay, now isolated, no exchange takes place. Here in this, if we take a diagram, if we take a beaker, it is a closed and it is made up of insulating. In insulating, no heat energy takes place. It's nothing but no energy. And as it is a closed, no mass energy, no mass takes place. No mass exchange takes place. So no energy takes place in isolated. Okay. So first, open type of system, mass energy and energy exchange takes place. In closed, only energy exchange takes place. In isolated, no exchange takes place. Okay, is it clear now? So now let's discuss next topic. It is thermal equilibrium. Thermal equilibrium. Thermal. What is mean by thermal? Thermal is nothing but temperature. Okay. So thermal equilibrium. What is mean by thermal equilibrium? I said that thermal is nothing but, as I said, what is mean by thermal? Thermal is nothing but temperature, as I said you, right? Now, temperature. So, for this, I'll explain you the help of a diagram. Suppose, if you take a large beaker, in this, if you pour one of the suppose liquid, it is consisting of one of the liquid. Okay. It is made up of a liquid. Then, if this is separated by a wall of suppose here A, B, A, B. Here I have drawn you case 1 as well as case 2. Here in the case 1, here we have taken one of the wall, if it is made up of conducting here, and in case 2 if it is made up of adiabatic. Listen here properly. This is very important thing or important topic in this. Here A, B, case 1, case 2 and conducting and insulating, right? Okay. Now here, in first of all we can teach case 2. Here in adiabatic, as I said you, no heat exchange takes place, so no temperature here. So therefore no thermal equilibrium takes place. Okay. Here it is a conducting which can exchange, right, energy. Here in this, as I said you, in conducting, if we take a conducting, energy exchange takes place. In energy, as I said you, it can be in the form of heat or work, right? So here the temperature exchanges from this wall, from A to B and from B to A, until they occupies thermal equilibrium. So by this I will say you, it is said to be thermal equilibrium when two bodies, see what it is an important, when two bodies gets equal temperature or when no heat energy takes place. When no heat energy takes place, when they are in thermal contact. I'll explain this. Listen here. Thermal equilibrium, which is based on temperature, or nothing but heat. Okay, heat. Okay. So this is not needed. This is the important. When no heat energy takes place, when they are in thermal contact. Here, these two are in thermal contact. Okay. Here, as I said, here heat energy takes place, but the system here, the equation, the definition what I said is no heat energy takes place. I'll explain you here. Here, heat energy takes place until they occupy same equal temperature or heat energy. Okay. For suppose A and B, let's take an A. Suppose here in A there is high heat energy, high here low. Then as I said, what is meant by thermodynamics? Heat in motion, right? Here, heat exchanges from higher body to lower body. Okay, higher body to lower body. So therefore, they occupies equilibrium. That is AA. They occupy same heat energy. Therefore, as they occupy same heat energy, then there will be no exchange takes place. So by that we said that when no heat energy takes place, only when they are in thermal contact, then it is called thermal equilibrium. Okay. In adiabatic, as I said, no thermal equilibrium because of it is an adiabatic which is made up of insulating. Okay. Is it clear? Now, next, go to zeroth law of thermodynamics. Zeroth law of thermodynamics. Zeroth law of thermodynamics. Okay. So what is meant by zeroth law of thermodynamics? You may have doubt. So by that name, zeroth law of thermodynamics means you will think that maybe some equation which will be equal to zero. Because I also thought in the same. So don't think in that way. What is mean by zeroth law of thermodynamics? We can discuss now. Zeroth law of thermodynamics. This zeroth law of thermodynamics leads with temperature. Okay, important point. Write it as a note. Zeroth law of thermodynamics which leads with temperature. What is mean by temperature? Temperature is measuring of hotness and coldness. Okay. Temperature exchanges from higher body to lower body. Okay. Three important conditions, or we can say the points. Zeroth law of thermodynamics leads with temperature. Here, what is meant by temperature means measuring of hotness and coldness, and the temperature will heat energy exchanges from higher energy to lower energy. It's mean that from hot to cold. Okay, is it clear until here? So here the SI unit of temperature is Kelvin, simply K, or degree Celsius. Degree Celsius is mostly, most common used. So this is the zeroth law of thermodynamics. Anyone have any doubts? Please check this. Anyone have doubts in this? So every point is written here. So zeroth law of the thermodynamics is nothing but which leads with the temperature and is measuring of hotness and coldness from higher body to lower body, I mean from hot to cold, and SI unit is Kelvin or degrees Celsius, which will be in degrees Celsius. Now, many people confused between temperature as well as heat. What is temperature? What is heat? Now, here I discussed you temperature. Now I will say you heat. What is mean by heat? Okay, heat. Heat is nothing but it is a thermal energy. It is a thermal energy that exchanges between two systems. Okay, thermal energy which exchanges between two systems. It is an energy, but temperature is not an energy. Okay, this is the difference between the temperature and heat. Many people will be confused. If I say that temperature will be constant, then all people will say that heat is constant. There is no heat in that. No, it's very wrong statement. Okay, here in heat, thermal energy. Heat is a thermal energy in which heat exchanges between two systems. Here, one of the things I have forgotten here, it is a scalar quantity. You know, scalar quantity and vector quantity, it will be in units and dimensions, right? So, it is a scalar quantity. Even heat is also a scalar quantity. And the SI unit of a heat is joules. Whereas, CGS unit is calorie. Okay, SI unit is joules and CGS unit is calorie. It is measured by calorimeter. Okay, 1 calorie is equal to 4.186 joules, which is approximately 4.2 joules. Okay, do you understand till here? Heat. It is a thermal energy which exchanges between two systems. It is a scalar quantity. The SI unit of heat is joules and CGS unit is calorie. It is measured by calorimeter. 1 calorie is equal to 4.186 joules, which is approximately equal to 4.2 joules. Okay, is it clear till now? So let's go to next topic. So here I'll say one of the important thing. What is the standard? You'll say that, right? Standard calorie. Okay. Standard calorie. Here I am writing a simple standard calorie. Here the standard calorie is 14.5 degrees Celsius to 15.5 degrees Celsius. Okay. And one of the formula to find external work done is equal to or internal something. So your work done will be PdV, where P is pressure, V is volume. Okay, where W is work done, or simply. Okay, till here understood, right? Standard calorie. Please remember these values. The values are very important. Okay, and the formulas also. W is equal to PdV. Okay, or else you can write the W is equal to integration PdV. Okay, where if I say, suppose we can say even PV also. Okay, where V is equal to V2 minus V1. Why V2 minus V1? Final volume minus initial volume, right? Therefore, we will get a change in dV. Okay, that is PdV. Okay, so now let's go to. So I think so. Every topic is this is the introduction of thermodynamics. Okay, please, if you have any doubts, please send it in there. So after this topic, we have Joule's law. Okay. So we can discuss this Joule's law in the next video. So until then, please bye. And if you like this video, please like it, share and subscribe this video. Okay. Thank you.